We might live in a multiverse. No, not that kind. Something more realistic. And this grand notion stems from a very humble idea. What if our universe expanded faster than we thought? I'm talking about inflation. Not of the sonic variety, you degenerates. Initially proposed in 1979 to explain why we haven't found any magnetic monopoles, the idea is that in the very early universe, the universe expanded exponentially quickly for a very short period of time. It turns out that this idea also solved other serious problems too, like the horizon problem and the flatness problem. However, it wasn't long until cosmologists like Paul Steinhardt, Alexander Vilenkin, and Andre Linde showed that, generically, such a mechanism would lead to more and more universes being born every moment. But these aren't separate universes like those found in the Marvel multiverse. In some sense, they're like islands or pockets of normal universe surrounded by a different kind of vacuum universe. Here, the space between universes grows exponentially, while the universes grow significantly more slowly. The only thing preventing you from going to another universe is the light speed limit. So let's get into the nitty-gritty. The simplest version of the story goes something like this. The universe starts out empty, with the exception of a quantum field that is very highly energized. Much like dark energy today, this enormous vacuum energy causes expansion, doubling in size roughly every 10 to the minus 37 seconds. Compare that with our current universe, which doubles in size roughly once every 10 billion years. However, the potential energy responsible for this enormously energetic vacuum isn't stable. Think like a ball at the top of a hill. If given a slight nudge, it'll roll down. Our quantum field is a bit like that. If it oscillates off that plateau just a little bit, it'll roll down and dump that energy, kicking off a Big Bang in the process. The trouble is, the field has that energy at every point in space, so the most likely outcome is that at one point in space it will begin to roll down the hill, and while it may infect nearby points of space, it can't spread faster than the rest of the universe is already growing. So you end up with little pockets with Big Bangs happening surrounded by space that is just itching to roll down the hill, getting further and further away. But every time the field rolls down somewhere, almost instantaneously, that location is isolated by the rapid expansion of the surrounding universe. While this is just the simplest version, all eternal inflation models, which is what they're called, basically amount to the same idea. So that's how we end up with a multitude of universes, with new universes popping up all the time just far, far away. Or we might, if this theory didn't have problems. See, back in 2013, the Planck mission took data from the cosmic microwave background radiation with unprecedented accuracy. And according to some people, including one of the originators of eternal inflation, Paul Steinhardt, this data basically ruled out many versions of eternal inflation. Now, I won't go into the reasons because they're apparently fairly contentious and also quite involved, but eternal inflation seems to be on shaky ground. Hopefully, with more data and better theory though, we'll come to a definitive answer one way or another.